Hey Warren, how are you? Almost Machining's here. We can start the party. Hey guys. Happy Sunday. It's a nice day out. Let me just go put this away. I'll be right back. I'll put it back later. You guys are coming in too fast. Precisely imprecise. Welcome aboard. So they got a new feature here. Let's see. Yeah, I could like your reply or like your comment by hitting it on the screen. I am fine. I'm doing great. Been a great week, busy week. Family stuff, lots of family stuff this week, and I'm very happy about it. But I was on the road all week, so it was kind of crazy. I drove more miles in traffic, miles in traffic this past week than I did in probably 2 years. It was crazy. That might be a slight exaggeration, but not much. So, yeah. I just had the doors open, and the guy that takes care of my lawn tractor came over to pick it up. Super nice guy. So my wife texts me and says that he's here, and can you open the shop door and just check if he's there and talk to him? So I opened the shop door, both the two shop doors that I opened, and I got to chat with him. And he looks in. He's never seen inside the garage, and he's a very competent mechanic and and he works in a machine shop. And he didn't know what was behind the doors. It was fun. We had a nice chat about machining and machine shops and tool room stuff. It was quite nice. Good guy. So interesting topics today to talk about. I'll wait a little bit to get started, but if you've been watching the posts, you know that I've been making some progress on getting the bevels into production. Making one bevel is one thing. Making 50 bevels efficiently is the big thing, is the hard thing. So we'll get into that a little bit. Hey Hassan, how are you? By the way, I hope you'll forgive me if I just guess your first name from your handle. MX Peter, welcome aboard. Indiana John, hey man, how are you? Sorry about the sunshine. I actually thought it might be a little cool, and I checked, and it was really quite nice out. Hey, I actually do have to run and make sure the thermostat's turned down so that it doesn't kick in, because that's the noisiest thing here. So I'll be back in about 30 seconds. Yeah, that's right. Guess the pronunciation of the names. But that's okay. I think we're all doing it in good spirits. All right, now the heat won't turn on, and it's also not really necessary today. We got warmed up in the morning, and it's warming up outside. So welcome aboard. And if you didn't know it, as I am now reminded, I will be on the Amateur Redneck Workshop podcast later today, I think 4 p.m. Eastern. Did I get that right? And that'll be a lot of fun. And I'll be doing that from the computer over there instead of the phone. So Amateur Redneck Workshop. I'll probably put the link up later, but it should be a lot of fun. Okay, so let me get into what's going on this week. It's been fun last weekend and a little bit during the week. I've been working on this project to get bevels on PFG Stones orderable and processable without a lot of friction. So you may have seen pictures of some test stones. You know, there's a 4-incher, and yeah, there's a chip here because I'm using stones that I rejected from making PFG stones. Yeah, Warren, come join us, man. Did I visit any maple sugaring houses this weekend? I did not. Am I a fan of maple syrup? I am. So I didn't go do that. But I believe Warren was out sugaring. Weren't you, Warren? I saw a really nice... Hey, let me answer this question. I want to work abroad. Can you help me? The answer is no. I'm sorry, I cannot help you. Yeah, nice recycling. Nothing goes to waste around here. But anyway, there's a bevel, and it did exactly what it was supposed to do. Look at that lip. So I'm watching the comments. I have a spreadsheet with a whole bunch of math behind it. You know, my grandfather was Turkish also. And I think from your handle, your name is Ismail. So do you know where Çanakkale is? How far are you from Çanakkale? Anyway, I have a spreadsheet with a whole bunch of math behind it. It pops out a label on my thermal printer, which is the same as for printing shipping labels. So this goes with the stone and becomes a traveler. This goes into my process. I reference off of the now missing corner. So if you make believe that this is the corner, I reference the wheel to that corner, hit a couple of buttons, fill out the form on the CNC control, and go. And I end up with this result, which is, if I don't say so myself, beautiful. And this surface that we just ground, that's a PFG surface. So PFG, 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 and PFG. The only thing we don't grind is the ends. So this is coming out awesome. So just to make sure, actually this was the second one I did, and then the first one I did was just as good. Okay. Same thing. Here's the traveler. So traveler goes with it and puts it in there. Now, how long to remove all of that? It was under 30 minutes. But we're going to talk about the how long, because part of the efficiency equation is how long that takes to do that. Okay? And so what I've been doing is tuning up my roughing. So, you know, the finishing. No, I disagree with you. It's not time to get a cutoff wheel. No. So let's get into it here, okay? If I could do something on one machine instead of two machines, that's efficiency. If I could do something in one operation instead of two operations, that's efficiency, okay? So if I, you know, floor space around here is very valuable. if I have to have a second machine and I have to move a second machine around, even if it's a little machine, and if I could figure out a way to not do that, that's efficiency. So taking one tool, yeah, unless it takes way longer. So yeah, there's a crossover, right? If you chart everything out and you decide when is it worth it and when is it not worth it. It's the same thing with the stones. I will tell you right now, and I know this by observation and just by extrapolation, it takes me longer to make PFG stones than it takes some other people to make their version of precision ground stones. Okay? But I could have a sandwich and answer emails and spend time with my kids while the stones are being made. I have cycle times that are long enough that I could hit the button and go in the house for close to an hour, or, you know, depending on what I'm doing. So because my cycle time is longer, does that make me less efficient? I don't know. I'm getting a lot done at the same time. Remember, I have other machines I have to feed at the same time. So if I have 4 machines going, am I being inefficient? Even though my grinding process literally takes longer. The second thing I want to ask, as a rhetorical question, is my quality. The quality of my grind is, I worked on it for 2 years to get it to where I think it can't be improved. Full stop. So that's the finishing end. Am I willing to compromise on the finishing end? No. So that's fixed. So now the only thing I could do is work on the roughing end. So when you say things like use a diamond saw, use a cutoff saw, that is a very efficient. Yeah, it's exactly like guys letting EDMs run overnight. I remember visiting a machine shop kind of before I was, years ago, and there was a CNC machine cutting what I now understand is a copper positive for a plunge EDM, and I said, "Oh, how long is that program going to run for in your CNC mill making the tool?" And he said, "Oh, it's going to run about 24 hours." And I was like, "What? Are you guys crazy?" Well, that was before I understood, and I understood that he had a 20 thousandths ball end mill in the thing, and he was, yeah, now I understand completely. Hey, Ismail, you're welcome here, but you're not welcome to shop for a job here. So if you want to participate in the discussion, please do. So anyway, that's the problem. Well, how do you do it? If you're going to work on making roughing more efficient, then a diamond saw is a great idea. But now you have to factor in, I have to buy a diamond saw. I have to have space for a diamond saw. I have to have 2 setups, one on the diamond saw, one on the grinder. There's just a whole bunch of things. Now I have support for a diamond saw. So I have to have, hey, Marv Grow, welcome aboard, buddy. Sorry to wake you. So now I have to have diamond wheels, diamond saw blades. Now I have to, so all of these things add up, and now it's like, am I really being more efficient to get my process from, let's say, 1 hour down to 45 minutes, except I have 2 machines, 2 setups, a whole new support chain. So it's an interesting, these are the questions I'm dealing with. So my choice is to stick with one machine. It's CNC. It may take longer, but it's once I get the process right, the thing doesn't need me standing over it. That was the goal for 2 years. So anyway, that's the challenge. So the challenge is not so much where am I going to buy a diamond saw to lop that piece off. By the way, this is the first time I'm showing you this. How many angles? Okay, I don't understand the question, Warren. There's you got auto corrected, and I don't think it's correct. Hey, AO Gold Service. Hey, welcome aboard. So the question is, how do I take angle stones? Now that I think of it, how many angle stones are you going to? Hang on, I want to get this question. Are you going to sell versus regular stone? Thank you, Warren. So Warren brings up an excellent point. If this is a minority product, why invest in hyper efficiency of doing something you're going to do infrequently? Warren, spot on. Exactly, I totally agree. Okay, Ismail, last chance. Either participate or you'll have to leave. This is not a place to shop for a job. I'm sorry, buddy. Last chance. So, the 6-inch, here's the 6-inch stone, and you'll notice that the 6-inch stone, just because of geometry, because of the thickness and the width, the 6-inch stone, boy howdy, that's a lot of material to go away. And it was over an hour to do that bevel. So I can just charge for that hour, and call it a day. And people may grumble. All right. Sorry, guys. I gotta just. Yeah. So, people may grumble at the price. I may not sell as many of them, but they're going to be super good quality, and I can make them. So I'm in sort of that place right now, but I'm going to go one more round with efficiency. Now, one of the things that we can do to make this more efficient, when we have to get rid of a lot of yeah. So Foxberg's Fabricoblin says, going back to the cutoff scenario, that waste, if it doesn't break, there's the cutoff part, wouldn't be bad as a thing to have as a smaller stone for a tighter area. Totally agree. But that's sort of a different direction to go in. I sell a lot of 4-inch and 6-inch PFG stones. You know that because you see my blathering about it all the time. I sell very few round stones, even though in many applications the round stone's a better choice. It's going to be like that. I'm going to sell a lot of 4 and 6-inch rectangular stones, but how many people want bevels? So again, am I going to keep the cutoffs and make something from the cutoffs? I'm not. This is crossing the line from a one-off to a production line. You have to make different decisions. So one of the things that I'm doing that's quite interesting is I am plunge grinding to get rid of material. And that's something that I don't think that the average grinder guy thinks about doing very much. But for this process on this machine, plunging to leave a margin for finishing, plunging, and plunging is a different way of thinking about it. And what happens is, all you have to do is use your ear and listen to what percentage of the time the wheel is removing material. And if you're removing more material a higher percentage of the time, you have a more efficient process. So I'm looking at reprogramming what I'm doing, and I'm going to do another. So what these were timed runs. So Marvgrow, I have personally not done high efficiency deep grinding on steel, and I would like to learn about it, because I think we're talking about a close cousin to that, except we're just not grinding steel. So Indiana John says plunging with an end mill instead of taking a lateral bite makes sense, but with a wheel, is there actually a difference? So it's very analogous. I think you bring up a really good point, is that sometimes when you get into milling like very deep pockets, it makes sense to go in and just plunge and remove material, and then go in and go back to your normal lateral cutting. In that sense, we're talking about the same thing, but don't confuse them. The work is still traversing. The table is still reciprocating, except you're just staying in one place and going down, 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 and then you come back up. You go move over and you go down, 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 down. Yeah, so that's what I'm talking about, and it seems to me like this is going to increase the efficiency a little bit. So these aren't exact numbers, but call that an hour's worth of work, okay? And now I go back and I change my process and I run another one. I have to invest in another stone. Somebody will be benefiting from the fact that I'm making these stones, and as part of engineering. And then we get out the stopwatch and we see how it works. And if it's better, it's better. But on my machine, I do have cycles, which are plunge grinding cycles, and I already use them, but now I think I have to use them a slightly different way. So yeah, I can't wait to try it. And I kind of wanted to try it today, but I've switched gears and I'm actually making some vice jaws today for my local makerspace that had some apprentice marks on their vice jaws. So I decided to switch over to steel, and I'm going to do that for them today. And I may go back and do my experiment. The experiment's all sorted out. I have it all figured out in my head. And if that's a better job, that's it. But I think I'm only going one more round of this optimization, and then I have to release a product because people are yelling at me. That was a lot of talking. So that's what's going on in PFG Stones world. You guys have any questions, topics, snide remarks? Now's the time. While you're thinking of your questions, comments, and snide remarks, I'll remind you that I'll be on the Amateur Redneck Workshop podcast event today at 4 p.m. Eastern. And I will post something about that after we're done here. Expected angles. Right now I'm going with a 40 degree chamfer. So that is 40 degrees. As we get warmed up and as this process improves, I will open it up to taking custom angles. Again, in my process, the angle is just another number to punch in. But right now we're going to go with 40 degrees. And I had an interesting question on, I can't remember if it was email or it was in a comment, is there any issue with having, two different grits here? And the answer is no, there's no issue with that at all. But on the other hand, if you're stoning the underside of a dovetail, you could also flip it around and stone the underside of the dovetail and use whatever side here. And then when you order the stones, you can specify which grit you want to leave whole. Okay. Are dovetails in machine ways usually 60 degrees? Yes, I think I've heard. Well, okay. Hey Marv, thanks for stopping in, man. And we'll talk to you later. I was bragging about you to my son the other night, and I explained to him your whole thesis, and he got it. It was pretty cool. Anyway, have a great day, Marv. To my knowledge, dovetails are frequently 60 degrees, but I wouldn't say always 60 degrees. And I think there's some 45 degree stuff out there, so 40 degrees made sense. So, for example, if you were only working with 60 degrees and you wanted a 50 degree dovetail, I don't see a problem with that. From a business standpoint, I have to figure out a way such that you specify that on your order. It comes in on your traveler. It'll say, 50 degree stone. Maybe it'll even have your customer number here or your order number here. This isn't done yet either. And then we make it 50 degrees. It's not that hard to reset that angle. So that's a possibility. Okay? Remember, this is all customer driven. So if you guys tell me we need 50 degree stones, not 45 degree, or not 40 degree stones, fine. But we're going to start with 40 and we could adjust from there. Okay? Warren says bridge ports are 55 degrees. I have seen 45 degree ways as well. So again, I'm motivated to stick with 40 degrees. But I'm listening to you guys. If you say to me it needs to be something else, we'll make it something else. But I'm digging the final product. I mean, this guy, I may have had to wait for this guy longer than I wanted to, and maybe I could squeeze some more efficiency out of my roughing process to get the time down, but the quality is spectacular. And I measured my lip, because it goes through a ton of trigonometry to spit out the numbers for the CNC machine. And, you don't believe this stuff until it actually comes out the other end. And sure enough, I specified a 50,000th lip, and I've got a 50,000th lip. And that's the other thing that I kind of want to ask everybody is I picked 50 thousandths out of the air. I thought that was a reasonable amount to leave us with a strong lip, and it's probably narrow enough for what you're, for getting into the clearance on a dovetail. And if that needs to be a different number, then I need to know that. And theoretically, that could be another number on the order. I don't want to make too many variables in the ordering process. That doesn't end well. But we could always do a custom. Yes, Warren. Yes, I do. Yes, I do realize that. Absolutely. So Warren actually, if you were here was it last week? Yeah, it was last week. Warren had the first experimental 4-inch that we did with a 45 degree and a 40 degree. Yeah. Yeah, maybe we'll talk more about this later. This is one of those things. It's a religious argument. It's like I'm just here to serve the customer. But I think 40 degrees is going to make the maximum number of people happy. And it's pretty. It takes the longest time. Okay, almost machining is going to go make a measurement, give us another data point. But that'll be interesting. So yeah, it's fun solving the puzzle of efficiency in manufacturing. You know, making one of something is one thing, making 1,000 of something is another. So I'm pretty pleased with how it's going. And I still think somebody's going to wince at the price, but I'm not going to make junk. I watched a video the other night. I'm not going to name names, and the person makes a stone on a grinder with a diamond wheel, and then feels there's a need to lap it and do some lapping. And I was like, okay, that's a different process, totally different from mine. But those are the things that make you go, okay, that's different. So anyway, so what else is going on with you guys? What is happening out there? What do you want to talk about? Nice. Yeah, of course. Yeah, of course. So Indiana John says, can you tilt a 40 degree bevel stone for use in, say, a 50 or 60 degree way? Here's the important thing to know about. All you're looking for is clearance. This is the most important sentence I'm going to say all day on this topic. You are only stoning one flat surface at a time. You're not jamming a stone in, having it contact two surfaces, and then working it. That is not how you use these, okay? So you need an angle here that is smaller included angle, a smaller included angle than the angle of the dovetail. Okay, not exactly the size of the dovetail. That is wrong. So if you have a 60 degree dovetail, you say, well, give me a 60 degree stone. No, incorrect. So you're going to go in there, like here's your dovetail, right? You're going to go in there and your stone is going to be tilted up to work it this way. And then if you want to do the flat surface, you're going to put this flat, go in, and you're going to do it this way. And the dovetail will be missing. You will not be touching the dovetail. Okay? That's a very important thing to know. You're never stoning two surfaces. .50 is close. They don't machine to a pure angle. The end user could remove. Okay, so what I hear you saying is 50 is close. So can I interpret what you just said as 40 degrees? A 40 degree bevel is good? I think that's what you're saying, almost machining. So this is a 40 degree included angle right here. So if you have a 50 degree bevel, you're all set. Okay, so I think we're in violent agreement that a 40 degree included angle is still good. Yeah? Okay, so the great irony is that, like Warren pointed out before, we're going to probably be selling a small fraction of the stones that we sell with bevels. It's going to be a very small fraction. So we'll be able to help. Okay, yeah, this was a question I wrestled with, Warren. Warren says that the bevel is only for clearance okay? And it doesn't have to be anything but clearance. I get you, and I thought about it, and yes, it would save time on the process, but boy howdy, you know somebody's going to use it. So if I sell a stone with a non-PFG surface and somebody goes to try to use it and they screw something up, that's just, I don't want to do that. I don't want to go there. Larger is better for the user. Too thin, it becomes brittle. User can make final adjustments. I agree with everything right up until user can make final adjustments. After that, it's out of my hands. Warren says, yeah, right. Yeah, Warren, this whole discussion, which is now happening with a dozen people, started with 2 people, me and Warren, like chewing this over. So I think it's going to start out good. And like I said, everything could be customized. Some of the customization will be easy. Some of the customization will be hard. Easy is cheap. Hard is expensive. It's not complicated. So we'll see what happens. I want to make some people happy. I just don't want to make everybody happy. Yes, Warren, you're right. A PFG surface is not a bad thing at all. And, if you make it, somebody's going to figure out how to use it. Especially Dan, who just showed up. Hi, Dan. Dan, for your benefit and those of us just joining us. Yeah, exactly, Warren. We've been talking about bevels. Not so much that we're going to be making bevels, because we're obviously already are making bevels, but the efficiency of how to make it and how to do it in an efficient manner. So that's where we've been this is what I wanted to talk about this. I wanted to hear what you guys had to say, because I care about your opinions, and you're gonna have ideas that I don't have. But so far, nobody has looked at the 40-degree angle and said, that's terrible. That's the wrong thing to do. So we have them, there's the 4, there's the 6. And the cost of the bevel right now is 3 to 1. Okay? So I'm trying desperately to get that time down. Okay, what other questions do we have today? Questions, topics, snide remarks. No politics. A question came in on the question button. Please stand by. Let me get back to that question almost. Okay, actually, almost. I'm going to take your question right now. Can a PFG stone be made to cut at a particular level? Say more than just polish. I'm trying to understand what you're asking. Yeah, Foxberg's Fabric Goblin says, I think the angle is perfect. I do ponder the thickness of the narrower end in the inside corner of a way. Right. So I chose a blunt nose of 50 thousandths height. And if somebody wants to push back on that, I am open-minded. There's a second half. Okay, let me look at your second half. So we're going to take Indiana John's questions. I need to make a cart for my phase converter, and I'd like it to be enclosed for noise reduction. But I don't want the motor to overheat in a box. It's a 10 horsepower motor. So Yeah, hang on. I'll get back to the coarse fine question here. In my experience, the only thing that makes noise on is it a rotary or is it a solid state? I'm assuming it's a rotary. My knee-jerk reaction to your question is this: move it outside, make a shed for it, and get it out of the shop if you can. It's easier to move the noisemaker and then run longer wires than it is to make it quiet and have it not overheat. Yeah. So I'm going to recuse myself a little bit here because I don't have experience with rotary phase converters. I recognize that you've got a heat issue and you do not want that thing to get too hot. That's a bad thing. And you got to move air through it. So the air movement is going to be another problem. If you could get it outside in a shed, or little shed, in a doghouse, I would do that. Okay, that's my knee-jerk reaction. Okay. Okay, there's a little discussion going on here about. Okay, so when you take a raw stone that has not been PFG surfaced, yeah, okay, we have some agreement on moving your rotary outside. When you take a raw stone that hasn't been PFG surfaced, number one, it's not flat. But let's just assume for the moment that it's flat. But also it has grains, which are relatively sharp. So displacement of material happens based on pressure, pounds per square inch. When the pressure is high enough, the harder thing will go into the softer thing. Let's say that again. When the pressure is above a threshold, okay, the hard thing is going to press into the soft thing. That's why a stone cuts. Whether it's a grinder wheel, whether it's a hand stone, is you're putting pressure on it. You get pressure on all the contact points, and when that pressure, pounds per square inch pressure, exceeds the threshold of that material's hardness, it will move into the material. And presumably you're moving it so it's going to cut. The magic of a PFG surface, and any precision ground stone, but I like to use my trademark, is that number one, it's flat. And number two, any of the points have been flattened. Okay? So now, when you put 10 pounds of pressure on a PFG stone and you put 10 pounds of pressure on an out-of-the-box stone, the out-of-the-box stone on a perfectly ground surface is going to develop enough pressure in multiple spots to displace material. The PFG stone, which is flat as the perfectly flat surface, when you put your 10 pounds of pressure, there is no place where the pounds per square inch exceeds the threshold. It will not cut. In a short paragraph, that's the whole point. And that's, if you go to pfg.gg, I kind of explain that. I have a couple of photo micrographs so that you can kind of see what's going on. So now we ask, well, what if you make a PFG stone out of a coarse stone versus a fine stone? Okay? And the answer is there's no difference in its operation except for the holes where the swarf goes. Okay? So if it's going to remove material, the holes on the coarse material are bigger for swarf to get into than on the small one. So you can't. There's no such thing as coarse and fine once it's PFG ground. All right, buddy. Hey, Warren, thanks for coming. We are. Yeah, I want a picture of you sitting in your yard and looking pretty. Oh, okay. Oh, your road grader sitting in your yard and looking pretty. All right, see you later, Warren. So Foxburg's Fabric Hobbling says, so there's only a couple of guys in here, PDF, PFG versus Arkansas Stones. Sorry for the spelling. Okay, oops, slow down. Burp, burp. So Foxburg's says, since Arkansas Stone versus PFG Stone. So PFG is a surface grinding process. We're making it dead flat. If you handed me an Arkansas Stone, the material may be different, but it either is or it isn't dead flat. So Arkansas stones are very dense. So if we PFG ground, believe me, I have Arkansas stones. I looked at them. They have no place for the swarf to go. Let me say that differently. They have microscopic. They have tiny places for the swarf to go. Tinier than this, right? So would it work? Yes. Would it be useful on, rougher work? Notice I said the work is rougher. So if I'm, like today, well, here. I practice what I preach. I just reground the faces of some Kurt Weissjaws, okay? I haven't done that side yet. Can you understand what I'm dealing with here? Okay, but I did that side. And in order to set it up, I had to stone the back. Now, the first thing I did is I stoned it as a diagnostic tool. So when I used my stone, okay, and I stoned it, it generated some bright spots, and I was able to read the surface and see what was going on. And in general, it was hitting, here and here, which means that this block has a belly in it. And it turns out it's not much of a belly, and for a Weissjaw, I wasn't going to turn this thing into a cut diamond, So I stoned it. I went over to the Lapzetti plate, which is 220 on a surface plate. I hit it there much more rigorously so I could actually remove material. And I kind of got these ends starting to brighten up here. And then I stoned it again to make sure there's no burrs and to evaluate it. And then I looked at the marks that the PFG stones made. I evaluated what was going on. I said, it is ready to go on the grinder. And then it went that surface down on the grinder. And then we got that, okay? So what side of my PFG stone did I use on this guy? The coarse side, because I expected burrs that I was literally going to be working down. Why can a PFG stone work down a burr? Because the pressure on the burr is high enough to cut. As soon as the burr goes away and everything's flat again, the pressure drops and there's no cutting. Does that make sense? Yes? Feedback, please. Okay. So, there you go. I can take an Arkansas stone and I can precision flat grind it. I could PFG it. And if you think you have an application where an Arkansas stone's the right thing, let's talk. But there you go. You got me all worked up. All right, what else do we have? I think there was another question I might have put off. I don't think so. I think we got everything. Indiana John says it totally makes sense. That either means I did a really good job or you're just tired of listening to me. It could have been either one of those. Okay, yeah, Indiana John, you said, speaking of swarf loading into a stone, how do you recommend cleaning that out? So the answer is on the webpage. Ultrasonic cleaning is an excellent way to get that stone cleaned up. And another excellent thing to do is clean often. In other words, just use some solvent. One of the techniques one of the guys came up with is solvent on a piece of corrugated cardboard. Just put WD-40 on corrugated cardboard and work the stone on it. Does it work? Yeah. Is it going to hurt? No. Do it more often. If you pack the pores before you start to decide to clean your stones, it could be super hard to remove. Hey, CNC guy. Yes, it is awesome that it stops cutting when you're done. How do it know? Yeah, burnishing versus abrasive. So go think back on a microscopic scale. It's super simple. You got a hard material and a soft material. And if the hard material can put enough PSI on the soft material is going to give way. Can you grind? Okay, here's a quiz for you guys that have grinders. Can I give you a piece of glass? Let's say I have a piece of glass that's this shape. You grab it in your vise. Can you take a white wheel, a standard off-the-shelf white wheel, and grind the glass with it? This is a quiz, so I want to see what your opinion is. Can you grind glass with a white wheel from a grinder? And if not, why not? And if so, why? Give 3 examples. Just kidding. I'll drink some tea while you think about it. I'll give you 10 more seconds. Indiana John says you'd assume you could. Okay. He cautiously says yes. Okay. So I picked those maybe prematurely. Almost Machining says, yep, but it's going to be messy. Could also shatter the glass because of resonance. Guesses here, haven't tried it. Okay, the point I'm trying to get at is how hard is the aluminum oxide in the wheel and how hard is the glass? That's the only thing that matters. Hardness. So if the hardness of the glass is equivalent to the hardness of the wheel, it's going to be, pardon my French, a shit show. Yeah, normally you would run diamond with lots of coolant. Why diamond? Because diamond is way harder than glass. So you need a margin of the hard thing being this many times harder than the soft thing. And then you have a grind. How do you grind diamond? How do you grind diamond? Think about that. Yeah, and the truth is that an aluminum oxide is probably still harder than glass, but it's not going to be, tons harder. Yeah, you cut diamond with diamond. So that's an interesting question with mystery material. Yeah. You intuitively know that you will have to resort to tricks to grind diamond. All right. So the hard thing displaces material in the soft thing. I just described all of machining. All of machining. Carbide, high-speed steel, aluminum oxide, silicon carbide, CBN, diamond. The hard thing displaces the soft thing. If it's not displacement, the rules change. But this is mostly what we deal with. Okay? So that was a lot of fun, and you got me all wound up. So we're coming to the top of the hour, which is 2 o'clock. I'm going to give myself another hour to finish up what I'm doing here and clean up. And then I'm going to take a break, and then I'm going to be on the Amateur Redneck Workshop podcast at 4. They use alumina oxide in polish for lenses, so yes, you can do it, but it depends on the glass and the removal rates. Exactly what you're talking about. Yeah. So it's a little harder. And in fact, sometimes it's desirable for it to be only a little bit harder for reasons. But yeah, excellent answer. Kind of fun. I have 5 pounds of 5 micron aluminum oxide that I bought for a completely different reason. So I have little containers of lapping compound that I made with oil for stuff like that. All right. Last chance for a question, and then we're going to wrap this up because we're at 13:57 on the East Coast. For Marv Grow, that's, dinner dark 30. Hey, thank you, Almost. I appreciate it. I'm just having a good time. I think you could tell I enjoy this stuff. This is a lot of fun for me. And I'm a nerd. You're welcome. All right, guys, have an awesome weekend. It's Sunday. Spend some time with your family. At least 2 of us. Who was the other one? Oh, well, of course. You'll get me a tile saw. Listen, I have been thinking about looking at and considering tile saws for 3 years. So one of these days it'll happen. All right, talk to you later, guys. Go do something fun. Oh, you, me, and Phil. Okay. Go do something fun. Have fun in the shop. Be safe. And, go rescue somebody from their apprentices. See you later. 4 o'clock Eastern Time, Amateur Redneck Workshop. Watch my feed for a link.